Okay, what we're going to look at today is just a review for factoring and solving before we take this test. So in problems 1 and 2, we need to factor by finding the greatest common factor. So if we look at problem number 1, 16x squared minus 20x. The first thing we need to do is figure out what the greatest common factor between 16x squared and 20x is. Remember, we want to find the greatest number between 16 and 20, and then we take the lower of the exponent between x squared and x. So hopefully we realize that the greatest common factor between these two is going to be 4x. So we factor out the 4x. But now we need to figure out what's going to be remaining inside the parentheses. To figure out what's going to be remaining, we divide both these numbers by the GCF. When we're dividing that by that 4x, we divide the coefficients or the numbers, and then we subtract the exponents. So 16x squared divided by 4x is going to get me 4x. Negative 20x divided by 4x is going to get me negative 5. I can always redistribute that 4x to make sure I get that original problem back. So now you're going to try problem number 2. Let's see how we did. 4x squared minus 2x. So just like problem number 1, find the greatest common factor, which hopefully we realize is 2x. To figure out what's remaining, we divide both those terms by 2x. 4x squared divided by 2x is going to get me 2x. And here we want to be careful. Negative 2x divided by 2x, they're going to cancel each other out. It doesn't magically disappear. We're going to need that negative 1 as that placeholder. So our final answer is 2x times the quantity 2x minus 1. In the next set of directions, it says factor the trinomial completely. So for the trinomials, remember we want to figure out what's going to multiply to that last number, and it's going to add to that middle number. In problem number 3, we're given x squared minus 10x plus 24. So we need to think of everything that multiplies to 24 but adds to a negative 10. Here I listed out everything that I know that multiplies to a positive 24. Notice I did positive times positive and negative times negative. Here, the only combination that's going to work is x minus 4 and x minus 6. Notice the order doesn't matter, so I could have rewritten this as x minus 6 times x minus 4. But the signs are very important because I'm trying to get that negative 10. In problem number 4, I'm given x squared plus 8x plus 7. So I need to think of two numbers that multiply to a positive 7, but add to that positive 8. Here, hopefully pretty easy, we see there's only 1 times 7 to get me 7, which I can rewrite as x plus 1 and x plus 7. In problem number 5, we notice that there's 2x squared minus 2x minus 60. This is different than problems 3 and 4 because there's a number in front of that x squared. We should always remember that our first step for factoring is to see if we can factor out a greatest common factor. Between 2x squared, negative 2x, and negative 60, there's a greatest common factor of 2. So I'm going to factor out a 2. What I'm left with is now x squared minus x minus 30 by dividing all of those numbers by 2. I now need to look inside the parentheses of x squared minus x minus 30 and think, is there a way that I can factor this? Are there two numbers that multiply to a negative 30 and add to a negative 1? Hopefully we realize that when I list all my factors out, there is one combination that works. The combination is going to be x plus 5 and x minus 6. It's very important that we carry down that 2. That's part of my final answer. So it's 2 times the quantity x plus 5, x minus 6 for my final answer. In problem number 6, which looks pretty similar to number 3, I have x squared minus 10x minus 24. There's no greatest common factor, but I need to think of two numbers that multiply to a negative 24, but the same two numbers add to that negative 10. Here, one number is going to be positive, the other one's going to be negative to help me figure out what's going to get me to that negative 10. The only combination that's going to work is 2 and negative 12. So I write x plus 2 and x minus 12. I can always multiply this binomial times binomial and make sure I get that original trinomial back. Now, in the next set of problems, I need to solve. Notice my problems change because I have an equal sign. So I have the equation I need to solve. Our steps when we're solving is we want to make sure it's set equal to 0. It's in factored form. We set each factor equal to 0, and then we solve. So in problem number 7, set equal to 0, check. In factored form, check. So I go right to setting each factor equal to 0. 2x is equal to 0, x plus 5 is equal to 0. I solve each of these, so I divide both sides by 2, and I subtract 5, and I get my two answers. X is equal to 0, and x is equal to negative 5. Both of these are my final answers. In problem number 8, I have this trinomial on the left-hand side of x squared plus 14x minus 15, and it's set equal to 0. So that first step is done. The next step is I need to factor x squared plus 14x minus 15. It's a trinomial, just like that in the previous set of directions. So I need to think of two numbers that multiply to a negative 15 and add to positive 14. If I list everything that I know that multiplies, the only combination that's going to work is negative 1 and 15. I realize this should be a 15 right here. So negative 1 and 15. So I rewrite x minus 1 times the quantity x plus 15 is equal to 0. I set each factor equal to 0, and I solve, giving me my two answers of positive 1 and negative 15. In problem number 9, it's not a trinomial. It's 10x squared minus 30x is equal to 0. It's set equal to 0. But only way I can factor 10x squared minus 30x is by factoring out the greatest common factor. So it will look like problem number 7. Between 10x squared and that negative 30x, I'm going to factor out a 10x, leaving me with x minus 3 is equal to 0. Notice how it's now similar to what we were given in problem number 7. I'm going to set each factor equal to 0, and I'm going to solve both of them, giving me x is equal to 0 and x is equal to 3. In problem number 10, it's not set equal to 0. So I need to set it equal to 0, which means I need to subtract the 90. Notice that I put the 90 at the very end, so it was a constant. So now I have x squared plus x minus 90 is equal to 0. It looks like problem number 8, so I should factor it as that trinomial. What two numbers are going to multiply to a negative 90 and add to a positive 1? So here's everything that multiplies to that negative 90. It's a lot of them. The only combination that's going to work is the negative 9 and the positive 10. So I say x minus 9 and x plus 10 is equal to 0. I now set each factor equal to 0, and I'm going to solve, giving me my two answers of x is equal to 9 and x is equal to negative 10. Now, let's look at what's going to happen when we put this in terms of the graph. So, in problem number 11, what are the zeros or the x-intercepts to the quadratic function? F of x is equal to x minus 8 and x plus 4. Imagine that we are also given this graph. So here's my xy axis. We need to find, this obviously isn't the right graph, but we need to find these x-intercepts. So the x-intercept is when the y-coordinate is equal to 0. So I'm going to take the equation that I'm given, and I'm going to set the y-coordinate, or the f of x, equal to 0. I'm now just going to set each factor equal to 0, and I'm going to solve for x. So I get two answers for x. I get x equals 8 and x equals negative 4. Just their opposites. I want to write this as an ordered pair, though. So how I write it as an ordered pair, it would be 8, 0 and negative 4, 0. Do not combine them and say 8, negative 4. It's not one big mega point. It's two separate individual points. When x is 8, the y-coordinate is 0. When x is negative 4, the y-coordinate is 0. They're two separate individual points. Okay. Now, in the last two problems, we're looking at that modeling problems that we did. If the area of the rectangle is 24 square feet, solve for x and then find the dimensions. So when we did this in that last ed puzzle, we talked about how that the area is equal to the length times the width, or length times width is equal to area. So what I'm going to do, my length is x plus 1, my width is x minus 4, my area is 24. I'm going to plug all that into my equation. I'm now going to multiply this binomial times binomial, which I can use that box method, or I'm just going to distribute, giving me x squared minus 4x plus 1x minus 4 is equal to 24. The next thing I did was I combined like terms. So now I'm looking at x squared minus 3x minus 4 is equal to 24. Whenever I see this x squared, I need to solve by factoring. So those steps again, set equal to 0. So here I go subtracting the 24. Now I see that I have x squared minus 3x minus 28 is equal to 0. Think back to that previous page when we were solving. Think of numbers that multiply to a negative 28 and add to a negative 3 because I have this trinomial with no GCF. Here's everything that I know that multiplies to negative 28. Only combination that's going to work is the 4 and negative 7. So I rewrite this as x plus 4 times the quantity x minus 7 is equal to 0. Set each factor equal to 0 and solve, which means that I'm looking at negative 4 and positive 7 as my answers. If we think about this application problem with a rectangle, let's figure out why I put a cross of x through this negative 4. If I plug in negative 4 for x, I get a negative number for both the length and the width. And I can't have a negative number when I'm talking about length and width. Whereas if I put in 7, I get a positive number for both the length and the width. So that means that x is going to equal 7. The length is going to get me 7 plus 1, or 8 feet, and the width is going to get me 7 minus 4, or 3 feet. As a last check, I know that 8 times 3 does in fact get me to 24. So I'm going to have you try the next one on your own, and then we'll check it. So in this next problem, number 13, our last one, here our area of the rectangle is 22 square feet. Solve for x and then find the dimension. So very similar. So work through the problem when you're given x minus 5 feet for the width and a length of x plus 4 feet, and the area is 22. So hopefully we set up the equation. We've multiplied the binomial times binomial correctly to get x squared plus 4x minus 5x minus 20 equals 22. We combine like terms to get x squared minus x minus 20 equals 22. We set equal to 0, which means we subtract the 22. So now I'm looking at x squared minus x minus 42 is equal to 0. This trinomial we have to solve. So everything that multiplies to negative 42, only combination is going to be 6 and negative 7 to get me to that negative 1. So x plus 6, x minus 7 is equal to 0. Set each factor equal to 0. Our two possible solutions are negative 6 and positive 7. In this application modeling problem, negative 6 is no good because then we're looking at negative length and widths, which means that 7 is going to be our answer for x. Our length is going to be 7 minus 5, or 2 feet, and our width is going to be 7 plus 4, or 11 feet. Just as a last check, 2 times 11 does in fact get me that 22 feet squared.